10th CBSE Mathematics, Chapter Arithmetic Progressions. After watching this video, you will be able to identify an arithmetic progression when a sequence of numbers are given. Write the terms of the arithmetic progression when the first term and the common difference are given. For a given arithmetic progression, you will be able to find the first term and the common difference. Let us look at a honeycomb. The honeycomb is made of hexagonal pattern of wax cells. In a pine cone, we have scales. These scales are spirally arranged in a pattern. In a maize cob, we have kernels. These kernels are arranged in rows. So all these things follow a certain pattern. Suppose we have the list of numbers 7, 14, 21 and 28. Each of the numbers in the list is called as a term. Let us mark T1 as 7, T2 as 14, T3 as 21 and T4 as 28. Let us look for a pattern and find the term T5. To find the pattern, let us first find T2 minus T1, which is equal to 14 minus 7 equal to 7. Let us find T3 minus T2 equal to 21 minus 14 equal to 7. Let us find T4 minus T3 equal to 28 minus 21 equal to 7. Here we see that 7 is the fixed number and it is the common difference between consecutive terms. Between T1 and T2, the common difference is 7. Between T2 and T3, the common difference is 7. Between T3 and T4, the common difference is 7. Now that we know the pattern, let us find the term T5. So T5 is equal to T4 plus 7. T4 is 28 plus 7, which is equal to 35. So the T5 term is equal to 35. Now let us look at this stack of blocks. Let us write the number of blocks in each row. In this row we have 4 blocks, then next row we have 3, here we have 2 and then we have 1. Now let us find T2 minus T1, which is equal to 3 minus 4 equal to minus 1. Let us find T3 minus T2, which is equal to 2 minus 3 equal to minus 1. Let us find T4 minus T3 equal to 1 minus 2 equal to minus 1. Here we can see that the fixed number is minus 1 and the difference between consecutive terms is minus 1. Suppose I had to find this term, that is T3. Then for that I have to look at the term T2 and add the fixed number, which is minus 1. So we have 3 plus minus 1. So 3 minus 1 equal to 2. Hence we get T3 as 2. These two lists of numbers that we have written is said to be in arithmetic progression, because in these two lists of numbers, each term is obtained by adding a fixed number to the preceding term except the first term. Now here, because the difference between the numbers is minus 1, we say that D is equal to minus 1. Here A is the first term, which is equal to 4. In this case, D is equal to 7 and A is equal to 7. Since we have understood how to find if the list of numbers are in arithmetic progression, let us look at this list of numbers 9999. Let us see if it is in arithmetic progression. For this again we find T2 minus T1, which is equal to 9 minus 9 equal to 0, and then let us find T3 minus T2, which is equal to 9 minus 9 equal to 0. Since the common difference between the terms is equal to 0, hence we can say that this list of numbers is an arithmetic progression. Here d is equal to 0 and a is equal to 9. Hence we have seen that d can be 0, d can be negative, or d can be positive. Let us look at this list of numbers 7, 14, 21, 28, 4, 3, 2, 1 and 9, 9, 9, 9. These are called as finite AP because these list of numbers have finite terms. If we had a list of numbers like 5, 10, 15 and it goes on, or -5, -3, -1 and this list goes on, then these are called as infinite AP, as we do not know the last term of this list. Now the general form of an AP is given by A plus D, A plus 2D, A plus 3D and it goes on. This is the general form of an AP. Let us solve some problems on arithmetic progression to understand the concept better. Let us see this list of numbers 7, 10, 13 and 16. Let us find A and D for this list of numbers. A we know is the first term, so A is equal to 7. To find D, if we subtract T2 minus T1, we'll get D. So 10 minus 7 is equal to 3. So we have found out A as equal to 7 and D as equal to 3. Now let us look at another list of numbers, which is 14, 9, 4, -1 and -6. Let us find the next two terms or two numbers in this AP. Let us mark the terms. It will be T1, T2, T3, T4 and T5. So what we have to do is we have to find T6 and T7. Now let us first find D, which is T2 minus T1, which is equal to 9 minus 14, which is -5. To find T6, we can see the preceding term, which is T5, add the difference D and we should get our T6. So T5 is -6 and D is plus -5. So the answer is -11. Let us look at the T7th term, which will be T6 plus D. T6 is -11 plus -5 is our D. So it will be -16. So the next two numbers in the AP are -11 and -16. If A is given to us as 0 and D is given to us as 2, let us write the arithmetic progression. Now we know that the general form of the arithmetic progression is A plus D, A plus 2D and it goes on. Since we know A and D, so we can write 0, 0 plus 2, 0 plus 2 into 2 and it goes on. So we have 0, 2 and 4 as the arithmetic progression. Let us take an example. The sum of interior angles of a triangle is 180 degrees. The sum of interior angles of a quadrilateral is 360 degrees. The sum of interior angles of a pentagon is 540 degrees. If this pattern continues, then we have to find the sum of interior angles of a hexagon and a heptagon. Let us first write the list of numbers given: 180, 360 and 540. Let us mark the terms. T1, T2, T3, T4 and T5 are the terms that we need to find. Let us first find D, which is equal to T2 minus T1 equal to 360 minus 180 equal to 180. Now to find T4, let us look at the preceding term T3, add the fixed number D to it. So we have 540 plus 180, which is equal to 720. Let us find T5. For this we take T4 and add D. So we have 720 plus 180, which is equal to 900. Hence we have found the sum of the interior angles of the hexagon as equal to 720 degrees, and we have found the sum of the interior angles of the heptagon as equal to 900 degrees. In this video, we have learned to identify an arithmetic progression when a sequence of numbers are given, to write the terms of the arithmetic progression when the first term and the common difference are given, to find the first term and the common difference when the arithmetic progression is given.